Hello everyone, welcome back to my channel. So today I'm going to show you a very special tool that I've built, something that bridges AI agents, explainability, and safety in automation. So it's called the File System Autonomy Desk. It's a transparent React agent, so reasoning and acting agent, that's built over the Model Context Protocol, or MCP for short. So this project, it lets an AI agent perform real file operations like listing files, reading contents, writing new data, and even creating new folders. But with one key twist, every action is logged, visualized, and it's human approved before anything destructive happens. So before we dive into the demo, let's talk about what MCP actually is. MCP, the Model Context Protocol, is an open standard that defines how AI models communicate with external tools in a secure and structured way. So you can think of it like a universal adapter between the model and the real world. So instead of letting an LLM directly access your files or APIs, MCP defines a safe and transparent layer where every call like list files or read files or delete file, it goes through an MCP server that validates, executes, and returns results back to the agent. So that's exactly what I've used here, an MCP file system server. So the file system autonomy desk, it sits on top of this MCP server and it acts like an intelligent React agent. So you give it natural language commands like give me a list of all the files in this folder, or can you tell me what the contents of test.txt is, and so on, right? So this agent, it thinks, plans, and acts transparently, and it shows you every step it takes. So in addition to this, each operation that the agent performs, it is recorded in a timeline and visualized as a directed acyclic graph. So you can see exactly how the reasoning flows from one step to another. I'm going to show you how this looks like in just a minute. Okay, let's start with something simple first, right? Let's try listing all the files in our folder. So I'll type in something okay, list all files in the folder. So I'm going to run this task. Great. So the agent has started with the thought that it needs to list all the files in the current folder. Then it calls the MCP to list files, right? And along with the path, so I've limited the actions inside a sandbox folder. And finally, it shows the observation. It has observed that it needs to list all the files in the sandbox, and here are all the files in our sandbox folder, right? So we have a folder called NYU, we have two text files called sample and todo.txt. Wow, okay. This is amazing, right? So everything is visible step by step. As you can see, the thought, the action, and the observation, along with the fetch results. And there's also a graph, right? You can see the agent's actions as a directed acyclic graph. So if I click on each node, I can also see the logs. I can see the exact time at which this action was performed. I can see all the other relevant information like the type of action, what kind of thought, or what kind of, so what uh, the agent thought about that particular action, and so on. And I can also replay the last action, the last task the agent has performed. So we'll get to this part in a minute. Now, but let's continue with the second example for now on. Let's read the contents of a file, right? Uh, okay, I'll say something like read the contents of sample.txt. Let's see what let's see what's inside this file. I'm going to run this task. Huh, interesting. So the same thing happened. The agent has first reasoned that it has first thought that it needs to read the contents of the sample.txt. It has then performed an action. It's called the MCP tool called read file, and it has passed the name of the file along with it. And it has observed, it has fetched that file, and it has observed that the contents of this file are hello world, right? It has so basically it has reasoned, performed the action, and showed us the result. So you can actually open and view the text right here, right? You can see what the contents of this file are. Cool. Okay. So there are no hidden steps, right? There's no magic. All the actions are entirely explainable of the AI agent. Okay. Now let's do something more fun, right? Let's create a new file and write something inside that file. So this is important because I want to show you how we can chain two or more commands together, and it'll be interesting to observe how the graph looks like for chain commands, right? Let's type in something. So let's say I want you to create a new file called, let's say, um, example.txt, and write this is an example for command chaining, right? Let's see what happens. I'm going to run the task. Hmm. Okay. You can see that the agent has thought that it needs to create a new file called example.txt along with the content that we passed. Uh, it is called the MCP tool write file along, and it has passed the path of the file and the contents of the file, and it has successfully written the new file. Okay, so this example didn't exactly show the chaining part. Let me rethink about a new prompt. Okay, let's change something here. Example for command chaining v2, and then read the contents of example1.txt. Now I think we're gonna see the chaining part. So let's see what happens. Yep, bang on. We've got our chained command working and nicely set up. So the agent has first thought that it needs to write the example file. So it has created a new file called example1.txt like we asked it to. Then it has written the contents called as an example for command chaining v2. So as you can see, the agent has observed that the file has been written successfully in our folder. Then for the second part, since I also asked it to open the file and read the contents of the newly created example1.txt file, it has successfully read the file, called the MCP tool, read file, and fetched the contents of that file for us. Here's the interesting part. Here's the part that I want to focus on now. The commands, they have been chained, right? So this is the first action that the agent has performed, and it has been linked to the next one. So I can actually click on each node here. Let me zoom in a bit. I can see what the agent has performed in each action. So it has first written the new file called example1.txt, and then in the next command it has also called the basically it has called two MCP functions, the write file function and the read file function. As you can see, I can click on every node and see what the exact actions that the agent has performed along with the timestamps and other relevant details. Now, let's do something exciting. Let's do something more sensitive. The destructive operation that I was talking about earlier. Uh, let's create a new folder, right? Something really interesting is going to happen now. So, like I mentioned in the introduction, is going to ask for a human approval before performing any destructive actions. Now, let's actually see that happening in real time. So I'm going to ask the agent to please create a new folder called Genic AI. Let's see what happens, right? So here's what's going to happen. Before I hit run, it's going to pause. It's going to ask me, the human, to approve the creation of a new folder called Agentic AI. And only when I click approve that action is going to perform, and then it's okay. Let me show you the contents of our sandbox folder before and after we create this command, right? Let me add that. Let's start chain our prompt. So list all the contents of the folder. Then please create a new folder called Agentic AI, and then list all the folders, list all the contents again. Let's see, something really interesting is going to happen. I'm so excited to show you what's going to happen when I click the run task command. Okay, interesting, right? So as you can see, the folder doesn't exist. The agentic AI folder doesn't exist, right? Yet. Now, the agent has thought that it needs to create a new directory called agentic AI in our current sandbox folder. Here's the interesting part. The app has paused, right? The action has paused. It has asked for my approval to create a new folder. Now, that is the built-in safety that I was talking about. There are no accidental creations, there's no rogue behavior. We, the humans, we stay in full control of all destructive actions. So let's click on the approve part. So our new folder has been created successfully. And as you can see, as I had asked it to list the contents again, it called the MCP function list files, and now our new folder called Agentic AI has been successfully created. Pretty cool, right? So this time our action graph, it looks a little bit different because so we first asked the agent to list all the files, right? As you can see here, it listed all the files. Agentic AI, the new folder wasn't present before. Then the agent thought that it needed to create a new directory. So this, I want to focus on this node because this is the part where the agent paused and waited for our approval, right? You can see that it thought that it needed to wait for the human, right? So when I clicked approve, then and only then it created the new directory called agentic AI. And then, of course, we asked the agent to list the contents of our sandbox folder again. So that's these three nodes are related to that command. So this is the interesting part, the DAG, the directed acyclic graph visualization. Every run of this agent is logged in a JSON L format. So each step, it includes the thought, the action, the observation, right? The timestamp and even the approval status, as you can see here, right? See, the approved is true here because right after this step, the observation pending step, I clicked on approve. Right. So anyway, so this makes it so from these logs, we can generate a directed acyclic graph that shows how the actions are connected. For example, list files, read file, write file to create new folder. So this makes our app and our agent easy to audit, replay, or even visualize complex workflows later. So I can also select the past run, step through it, and understand exactly what happened. Let me hit replay last run here. So as you can see, we got our last action when we asked it to list all the files, create a new folder, and then list all the files again. I can see. what the agent performed in the last action. So all of these past runs are logged in our database. We can easily query and examine and inspect all the actions that the agent has performed. Okay, so why does this matter? In a world where our AI agents are gaining more control over systems, transparency and safety are critical, right? So this project, this tool that I've built, it demonstrates how we can make LLM-based agents explainable, auditable, and somewhat trustworthy. So it's like giving AI automation a black box recorder. So we want all the steps to be recorded and visualized. And because it's so modular, the same framework, I could later plug it into a Git MCP server or a database MCP or even a cloud storage MCP without changing the agent's logic, right? So, like I said earlier, it's like the MCP is like a universal adapter. I can just change the adapter, but the agent's behavior is going to remain the same thing. So that's the file system autonomy desk, a transparent, safe, and replayable agent running over an MCP file system server. So if you liked this project, please drop a like. Check out my GitHub repo linked below. I'll be building more MCP agents soon, including ones for Git and API automation. So please subscribe. And as always, my name is Ayush. I'm a master student, and this channel is dedicated to documenting my journey to an AI engineer. Thanks for watching, and I'll see you in the next one.